Hi, so today I'll show you how to do the RSI calculation for building assemblies, but I will show you the example with the wall assembly. And there are two types of walls. Build in 9.36 section building code talks about like when you have a wall like that, very simple, basic wall system where we have the just like the different layers. If I count from the outside to inside, it starts from um, the cladding and air barrier. There's no airspace in between them, no strapping. Um, um, like that, so no strapping is over there. The cladding, and right over there is the building paper or air barrier, and then we have the sheathing, and then we have 2x6 wall system with the cavity insulation in between, and we have the vapor barrier and the drywall. So this is like a very basic wall assembly. And to calculate the RSI value, effective RSI, not just only RSI, when we used to say about just the RSI, that is like we used to calculate the RSI value of each of those. We need to find out each of the RSI value of each of those material and then sum all of them and get the total RSI value for this wall assembly. In that case, what we used to do is just we consider for the framing part, because like in the framing part we have both the studs and the cavity insulation if you're having the cavity insulation. But now, so in that case, we used to just consider the insulation RSI value of the insulation. But 9.36 section now building code, it says that we have to consider both the studs part and the cavity insulation part, and that's why we call it effective RSI value. So for the effective RSI value for this kind of assembly, what we first have to, any kind of assembly, we first have to find out what are your layers are, building layers are, the materials are, and the layers are, and then the RSI value of each of those. So how we start is when we have this kind of situation, we consider from the outside to the inside. So outside, we consider that there would be a thin air film that is in close contact with our cladding. So we start from there. And that's why you would see that the very first layer from the outside is the exterior air film. Then comes our cladding. So whatever cladding you use, then the sheathing membrane, then the sheathing, and this is the framing part. This is the part where we actually use these calculation. A formula is there to calculate the RSI of this part where we have both the wood and the insulation part. And then we have our vapor barrier or polyvinyl sheet and the drywall. And similarly, that how we consider an exterior air film on the outside. So inside also we consider like a thin layer of air in contact with the drywall, and that gives and adds an kind of an amount of RSI value. And then when we sum up all those values, then we get the total RSI value of this kind of wall assembly. Now come to here. The exterior air film, if you go to the building chart, in the building code, there's a chart for the RSI value of all the materials. You find out the air films, and the exterior air film for the ceiling floor walls are same. This is a constant value, and in all cases we use that value. That is 0.03. That's how we start. And then the cladding. So here they used a very simple basic siding, and that has got the 0.11 value, and you can find out what is the cladding material over here. This siding, this is the thing that they use, hollow back siding. Then, as I say, the sheathing membrane, all the membranes like air barrier, vapor barrier, they're very thin. It's like there's not much thickness, right? Very thin sheet of membrane, or the building paper, right? So in that case, it doesn't add any RSI value, very thin, because RSI value depends on not only the type of material, but also the thickness of the material. So here, if we don't get any RSI value, that is kind of like the 0. Then the sheathing, 9.9 millimeter is our thickness of the sheathing, and you can find out whatever the RSI value for your sheathing is. Here when you have OSB, that is OSB, right? And if you don't find the exact thickness over here, then they have given you the RSI value per millimeter in the middle column. So you multiply this value with your thickness. So in this case, we have the thickness is 9 millimeter, right? So we don't have exactly 9 millimeter over here. This is 9.5, this is 11. So you can multiply 9 times 0.0098, and then you will get, get this value of that. Yeah, 9 times 0.0098. 0.0098, which is 0.09, right? Now let's come to this part where we have this formula for this portion. And the formula is 100% over. So in this case, you will see this our 2x6 stud wells, and studs are spaced in 24 inches center to center, right? So it's like from here to here is 24 inches. So when you have the stud spacing 24 inches from center to center, we consider that 20% of the RSI is being taken by the wood part, and 80% of the RSI is taken by the cavity insulation part. And so when we have that situation, I want to zoom, okay. So 20% over here, what is this RSI? This RSI is the RSI value of your wood stud. Okay, so and how we can find out, go to our structural materials over there, and here you would see the wood structural framing SPF, spruce pine fir, and they have given you the per millimeter what is the RSI value. So per millimeter is 0.0085, and you have 2 by 6, right, which is 5.5 inch thick, and which is equivalent to 140 millimeter. So what we will do, 140 times this, 140 times 0.0085, 0.0085 is that 1.20, right? Now similarly, we will find out 80% over the RSI value of the cavity insulation. So what they use 3.87. Now we'll go to our insulation part, and if you go here, you will see 3.87 is that one, because it is that they have given the thickness for each. They didn't give the per millimeter. They right away given you the thickness of. So if you're 2 by 6, 140. So those are the R value of your insulation. Now, if you have, this is for 3.5, like 2 by 4, 3.5 inch thick, then you will get that value. Okay? So in this case, we have 2 by 6. So we are using that. And that is 3.87, that value. Right? Now, we will do the calculation for this portion. Let me show you here. So this calculation will be like that. 100 over 20 divided by 1.2, and I just showed you how we got the 1.2 value, plus 80 divided by 3.87. 3.87 is the RSI value of the cavity insulation. Now you do the calculation. I'm doing that in my calculator. 20 divided by 1.2, which is 16.66. 0.66 plus 80 divided by 3.87, which is 20.67, hard to write with the mouse, but and we have the 100 here, right? So now if you add them, 16.66 plus 20.67, which is 100 divided by 37.33, and which gives you, oops, sorry, 100 divided by 37.33, and that gives us 2.67. So this is that value, 2.67. After applying that formula here and solving that formula, we get the RSI value for this portion is 2.67. Now, next layer is our vapor barrier polyethylene sheet, and as I say, the membranes, they don't add any RSI value. And then your half-inch drywall, which is whatever, like a 12.5 or 30 millimeter. What is the thickness? You can find out what is the RSI value. So if you go to the interior finish, and here the gypsum board, and 0.0061 is the per millimeter. Now, based on whatever your thickness is, if 13 times that, you will get the RSI value, right? Then the next part, the very, very interior portion, is the interior air film. Like we consider an exterior air film, so we also consider a thin layer of air in contact with our drywall. From interior side, that also adds an RSI value, a small amount of RSI value, which is that, and we get that from our chart at the very beginning when we got that air film. So you will see for the interior, it is different for the walls and the floors and the ceiling. So for the walls, but these are constant values. You can apply that any kind of assemblies. And now you will add this value, that one, and that one, and adding all of those values, you get the total RSI value for your this kind of building wall assembly. So this wall assembly has got the RSI value of 3.1. Now, next, another kind of situation, and in your case, we nowadays we use that. What is that I'm talking about is the airspace, or like we use the strapping in between our sheathing or exterior insulation and the cladding, right? Like to provide an airspace, to provide the drainage or drying layer. So in that case, Building Code 9.36 section says that when you have a air cavity, a vented airspace, in that case, what will be the situation and what will be the process of doing the calculation, RSI, effective RSI calculation? So what they said is that in this case, this airspace, you will consider that as your exterior air film. And that's where you are starting doing your calculation. What happens to the cladding? We don't consider the cladding for calculating the effective RSI value when you have an airspace here. And that will be considered as an exterior air film, and that's where we start doing our calculation. And it is mentioned over here, the insulation value of the cladding is not included in the effective RSI value when there is an vented air cavities, right? You can read this one, is that illustrated guide of 9.36 section. I think we uploaded that in Brightspace, and you all have seen that. Go over this if you have still confusion. So in this case, we'll start from this airspace. And again, like the same way, we'll start from the exterior air film, which is that same constant RSI value. Then your rigid insulation, again, like you'll find out based on your thickness and what type of material, you go to that chart and you will find out what the RSI value. Here, sheathing membrane, as I said, they don't add any RSI value. Your sheathing, so that is the sheathing RSI value of the sheathing. And now come to here, that again, like the same formula that we used before, that our effective RSI for this framing part, which has the cavity insulation also, 100 over. Now in this case, you will see that these value before we use the 20 and 80%. Why? Because our studs were spaced 24 inches center to center. But in not all cases we have 24 inches center to center, right? We may have 16 inches or we may have other numbers. So in the building code, you will see that in 9.3 section, you can check in the building code, they mention, if I go a little bit further. So here, this is the table where it shows you for the walls. And when 80% is when we have 24 inches. When we have 16 inches center to center, in this case, we consider that our wood part takes 23% and our insulation takes 77%, because now your studs are spaced close a little bit, right? 16 inches center to center. So that is the formula applied over here, because it says like your studs are spaced in between 16 inches from center to center. Right? The thickness is same, 5.5 inch. Now, so the formula is same, 100% over 23% divided by the RSI value of our this wood, and is the same value that I showed you before, the calculation, right? This piece, or your 140 millimeter is the thickness, 5.5 inch. 0.0085 is the RSI value of that, our stud, the wood SPF. So this times this gives us the value of 1.2. And here, this is the insulation, RSI value of the insulation. Now we will do the same way, 100 over, same way the calculation is 23 divided by 1.2, and then plus 77 divided by 3.87, and you do the calculation. When after doing the calculation, we get the RSI value of that for this portion. Okay? And then polyethylene doesn't add any RSI value. Our drywall is that. And then again, like the similar way, we consider the interior air film, which is again like the same constant value, 0.12. So we add this, this one, and this one, and adding all of those, we get the total RSI value of this kind of wall system is 3.76. Okay? So basically, that's how we do the calculation for effective RSI calculation. And you can check based on your spacing, framing spacing. They mention over here how much you have to consider for the framing, how much you have to consider for the insulation. Then yeah, they have like for the floors, for the roof, and for the roof, this is they have maybe like a little bit different numbers. So you can check this chart for that. And they also showed some example and showing how what they consider over here, the calculation, right? Yeah, they have shown some examples. That's steel framing. You will check for the wood framing. But again, the thing is, that's how we consider, we do the RSI, effective RSI calculation. And you can, like, we are Calgary is in zone 7A. So whatever is required in zone 7A, you will apply that, and you already know that, this chart, right? So yeah, that's the effective RSI calculation method. And if you have any questions, you can ask us in the class. Okay, thank you.